Jai Bharat to all students. In last lecture, we have discussed about Gaussian elimination method with the help of partial pivoting. Okay. In last 2 to 3 lectures, we discussed about Gaussian elimination method and how to solve linear equation. Okay. There are also another method which found by Gaussian and Jordan. So this method is called Gaussian-Jordan elimination method. This is also try to solve the linear equation. Okay, so there are if you want to solve linear equation, there are two methods: Gaussian elimination and Gaussian-Jordan method. We already talk about Gaussian elimination and also Gaussian elimination with the help of partial pivoting. Okay. So now in today's lecture we will discuss about Gaussian-Jordan elimination method. What is different between Gaussian elimination and Gaussian-Jordan method? Okay, it is a minor difference between these two methods. Okay, it is process will be same, but in some step there are minor difference in between these two methods. Okay, so now you all know row operation we will did in Gaussian elimination method. Okay, so in this method also we are going to do row operation. Okay, so first of all let me try with the what is the step in Gaussian elimination. We already talked about, right? First is transfer in augmented matrix. Transfer linear equation in augmented matrix. This is Gaussian elimination. Okay. Then what it is the next step? Transfer this augmented matrix in upper triangle matrix, right? Upper triangle matrix. Okay, then with the help of row operation, how do we transfer this augmented matrix in the upper triangle? With the help of row operation. Okay, and then after transfer this in upper triangle matrix, then how do we last step is back substitution. Okay, with the help of back substitution we solve the linear equation. Substitution. Okay, so this is the Gaussian elimination. Now what are the steps in Gaussian-Jordan elimination method? Okay, first of all this augmented matrix will remain same. We will transfer linear equation into augmented matrix. Okay, in both method first step will remain same. In second method we apply row operation also, but we transfer them into reduce row echelon form. Okay, we will talk about what is the reduced row echelon form. Okay, so in Gaussian-Jordan elimination there are only two steps. Okay, so in third we will get the answer of solution of linear equation. Okay, so this is the basic difference between Gaussian elimination and Gaussian-Jordan elimination. Okay, first step is same, transfer linear equation into augmented matrix, and in Gaussian elimination we did a row operation and transfer these types of matrix into upper triangle matrix. But in Gaussian-Jordan elimination we apply we done row operation but transfer this matrix into reduced row echelon form. Okay, we will talk about what is reduced row echelon form in our next 10 minutes. Okay, and then answer. Both our method are true. You can if in exam you have to solve the linear equation and they have not specifically asked which method you use, then you can use both, any one of these both method. Either you use Gaussian elimination or either you use Gauss-Jordan elimination. Okay, answer will be same. Okay, but in equation, if they have asked specifically use one of these method, Gaussian Jordan elimination, use with the Gaussian Jordan elimination, then you have to use Gaussian Jordan elimination. Okay, so this is the basic difference. Okay, now let's start with the Gaussian elimination. Okay, so there are no difference between in Gaussian elimination and Gaussian Jordan. Only we have to transfer these types of matrix into reduced row column form, not in upper triangle matrix. Okay, row operation will remain same. Okay, in last lecture we have talked about there are three types of row operation: interchange any row, first, second, third. If you change interchange row, then also you can write like this: 2 1 3 1 3 2 2 1 3 1. Okay, you can change any two row, but not column, only two row. Okay, multiply each element of row by a non-zero option, non-zero constant. Okay, for upper triangle transfer upper triangle matrix, we multiply with the second row and addition with the 3r1, like. Okay, so that will if this element will become 0. Okay, to transfer them into upper triangle matrix. Okay, so this is second operation: replace a row by the sum of itself and constant multiplication of another row matrix. These types of, okay, addition with the itself and constant multiplication of another row. So this is the three types of row operation. We already did these types of row operation in Gaussian elimination, but we apply row operation, but this in this Gaussian Jordan elimination we transfer this matrix into reduced row echelon form. Okay, we already know about Ri and Rj. Ri means interchange row I to row j. Okay, alpha Ri means replace row I with alpha times row I. Okay, like this R2 plus 3r1. Also here r1 plus alpha Ri j, replace row I with the sum of row I and alpha times row j. Okay, here what will we write in first row is we'll change the second row. Here we change the second row with R2 plus 3r1. Okay, like this. Okay, so now what is the reduced row echelon form? Okay, there are 4 steps to how to transfer reduced row echelon form, or what is the reduced row echelon form. Okay, you already know what is the upper triangle matrix: A, B, C, D, E and F. Here 0 0 and 0. This is upper triangle matrix. Now what is the reduced row echelon form? Then we will know how to apply row operation and how to transfer this matrix into reduced row echelon. Okay, so let's talk about first step. The row, if any, consisting entirely of 0 are grouped together at the bottom of the matrix if there are some linear equation, okay, in which all the member are, all the coefficient of are 0, coefficient of x, y, z are 0, then it will group together and it will be, we will transfer this into last bottom of the matrix, last row. Okay, if this all the 0 row are in between, is like a second row, so we'll transfer this second row with the last row. Okay, first step. Okay, now what is the second? In each row that does not consist entirely of 0, the leftmost non-zero element is a 1. Leftmost non-zero element is a 1. It's called leading one. Like if leftmost यानी कि left side you have each row you have leftmost consists as like 1. Okay, so this is okay. So let's talk about next step. Each column that contains a leading one, like this. Each row has a leading one. Okay, each column that contains a leading one has a 0 in all other end. If this is the 1 in first column, if we apply this 1, then all the elements are 0. Okay, here also second column 1 will have leading 1, all the elements are 0. So okay, and next step, leading one in any row is to the left of any leading ones in the row below it. Okay, leading one in any row. Let's suppose first row is a leading one like this. Okay, is any row is to the left side of the leading ones in row below it. Okay, so you can see that in second row we can apply any times in 1, but what is the fourth condition? Leading one of any row and its below will be the left side of the top row. Okay, so what these types of matrix is called identity matrix. We already talked about this. Okay, so now in simple word, what is the reduced row echelon form? This is the mathematical statement. Like now, for your better knowledge, what is the simple basic reduced row echelon form? Transfer augmented matrix with the help of row operation and transfer this augmented matrix into identity matrix. Reduced row echelon form is the one types of identity matrix. So we want to only with the help of row operation we will transfer this matrix into identity matrix. Okay, in Gaussian elimination we transfer this matrix into upper triangle, but in Gaussian-Jordan elimination we transfer augmented matrix into identity matrix. Simple reduce row echelon form. This is a simple Gaussian-Jordan elimination. But all other steps are between these two methods will remain same. Only we will transfer this matrix in identity and upper triangle. So in Gaussian elimination, this is the upper triangle matrix, and after that with the help of back substitution we solve linear equation. But in Gaussian-Jordan elimination we transfer this matrix into identity, and after we will solve the linear equation. Okay, so now let's say how do we transfer augmented matrix in identity matrix? What are the steps? Okay, so let's talk about what are the steps. Okay, so as I said, turn matrix into reduced row echelon form like identity matrix. Okay, so once this form is it is in this form, then we can say that here 1 is the coefficient of x, so x is equal to a, y is equal to b. Why? Because all other coefficient are 0 and z is equal to c. We directly write solution. In Gaussian elimination we have to solve with the help of back substitution. Like first of all we will find z, then we will put value in second equation z, and we will find y, then these two value we will put in first equation, and we will find x value. Okay, but in Gaussian-Jordan elimination we will get the answer of linear equation directly. Okay, so now row operation. How do we apply row operation? Okay, here are two methods to change the augmented matrix into identity matrix. Okay, first step is always this first leading 1, we will change this with the help of 1. Then second step we will remain in both method. First is remain same and second also remain same. Below element 1 are in the below are 0. We will apply row operation and we will transfer this into 0. Okay, so first of all we transfer this first column in 1. Then after that in first column below the 1 element all are the 0. Okay, so this first and second step will remain both the method same. Okay, now what third step is, we will make this element row a22 is equal to 1. With the help of row operation we will transfer this element into 1. This is the third step. And here also third step is the transfer this element into 1. So in both the method first, second and third step will remain same. Now in this method first step will make 0 below this element, make 0 below the 1 in second column. Okay, and then again with fifth step will be make the third row with the 1. Okay, so here you can see that they will first done diagonal element all the 1. Okay, so first they take a 1 value and transfer this in 1 and below the 0. Then second row operation 2 and transfer them into 1 and below are 0. Then diagonal element 3 and transfer them into 1. This is the first method. Okay, and then sixth step we will transfer this matrix into 0. So you can see that here if we did the operation up to fifth step, then this is the upper triangle matrix. Okay, so you can use the same method in Gaussian elimination in Gaussian Jordan, but one step will increase, like sixth step we want to transfer this element also into 0 form. Okay, so up to first, second, third, fourth and fifth, this is the same as the Gaussian elimination, like a upper triangle matrix, but one step will increase in Gaussian Jordan, like transfer this element into 0. Okay, and what is the second method? Here you, as I said earlier, first, second and third will remain same, fourth also will remain same, but in fifth we will done second column like 0. Fourth step will become second other than this one element, all elements will be 0. Okay, then fifth step will be diagonal 1 and then sixth step. Okay, so changes is the, you can use both the method, you can get the right answer. Okay, so let's start with some examples so you can get the better idea how to solve with the Gaussian Jordan elimination. Okay, here are 3 linear equations. So first step is the transfer them into augmented matrix. So coefficient 1 1 1 and 5 2 3 5 and 8. Third row 4 5. So 4 here coefficient of 5 is 0. So 4 0 5 and 2. Okay, so now we will perform row operation. So first is the 1, so we will not change the first row, first column. Okay, so now we want to apply here 0. This element will become 0. So how do we make this element 0? We already talk about in Gaussian elimination method also, like R2 minus 2 into R1. If we multiply with first row with the 2 and subtract with second row, we will get the 0, R2 minus 2R1. So first and third column will remain same and second row will become, this element will become 0. Now also we want to bring this element transfer this into 0. So how do we transfer? Like R3 we multiply with the 4 minus 4 R1. So this element will become 0. Okay, first step is clear now. First leading one and then below it 0 element. Okay, so now let's take as a second. Here you can see that this is the also second step is already done, is 1. So now we want to transfer below the element into 0. Okay, so how do we transfer this minus 4 into 0? Like R3 plus 4 R2. Okay, 4 R2. So this will become 0. Okay, R3 plus 4 R2. Now we want to next step is the this 3 column will transfer this into 1. So how do we transfer? So simple, if we division by or if we multiply with 1 by 13, then this state will become 1, right? Okay, so we will multiply row 3 with the 1 by 13. So here it will become 1 and minus 26 by 2 will become minus 2. Okay, so this 3 with we want this diagonal element as a 1. Okay, so this step will complete. Now we want to apply this into 0. Okay, this is this process is the same as a Gaussian elimination with till now this step. Okay, this is a upper triangle matrix. Okay, so with the help of back substitution we can solve the linear equation, but Gaussian elimination step are will complete in Gaussian element, but we want to solve this with the help of Gaussian Jordan. So we want this matrix transfer into identity matrix. Okay, so now first let's take this example and we want to transfer this into 0, or you can transfer this also 0, anything you want. You can also interchange row operation. Okay, so here R2 minus this R2 minus 3 R3. Okay, well, what row you can also say that if we want to transfer this into 0, we can also do the row operation like R2 minus 3 R1. Okay, we can also take this, or also we can both are the same, we will get answer 0. But if with the help of R2 minus 3 R1, so what will second row will be 1 1 1, R2 minus 3 R1. Here what we will get? R2 means 0 minus 3 R1 will 1. So you can see that here we will get minus 3. Here also 1 minus 3 into 1 we will get minus 2, or here 0. So you can see that in the one operation we want to take as a 0, but here you can see that this value will be changed. Okay, we want to this as a 0 over 1. Okay, not we want to change this the second operation. Okay, so this operation will not apply. So how do we make 0 of 3? Okay, so here R2 minus with the help of third row, not the with the help of first row. Okay, this is the help of first row. Okay, we get the 0, no doubt we will get the 0, but also we will change the other two element in the row. So we did the row operation like this with the help of third row, R2 minus 3 R3. Why? Because here you can see that x and y are 0, so that will not affect this second element, second row, these two elements. Only depend in this row. Okay, so you get the idea why I will not use the R2 minus 3R1 and but use the R2 minus 3R1. Okay, if we apply R2 minus 3R1, then we change these two element also. Okay, because row operation apply in all the row, not only one portion or one element. Okay, so this is become 0. Now we want to make this 0. So how do we make this 0? If R1 minus R3. Okay, now here you can also apply R1 minus R2 also. Okay, also you can take, but so if we apply R1 minus R2, then this will become 1 0 1 0 1 0 and 0 0 1. Here 1 will become same. Then so you can interchange these two operations. If first you can use R1 minus R2 or R1 minus R3, you can anything, any what. Okay, or first of all you can use R1 minus R2 or then R1 minus R3. Okay, so after numerous step in row operation, we want to transfer this matrix into identity matrix. In last we will get the identity matrix. Okay, and now final matrix we can read the solution of system like x is equal to 3, y is equal to 4 and z is equal to -2. Direct we get the answer with the help of Gaussian Jordan. Okay, so same as the Gaussian elimination with this step we do. Okay, and add extra step in Gaussian Jordan elimination because we want to transfer this matrix into identity matrix. Okay, so this is the Gaussian Jordan elimination method. Okay, so let's start with the next example. X 1 2 minus 3 6 3 minus 9 7 14 and minus 23 2 6 13. Okay, so first of all here you can see that this is the 1, so we will transfer this element into 0. How do we transfer? R2 minus 6R1. Okay, so second row will become 0 and then R3 minus 7R3, this also become 0. Okay, so you can see that here we obtain all the 0 except last one. Therefore we conclude that this system equation is inconsistent, has no solution. Okay, question completed. Okay, we will not make this is a 1. Okay, so this solution has a 0. Why? Because you can see that here -1. If all the value are 0, then this system has a we get the right solution. But here you can see that 0 plus 0 plus 0 is equal to what we will get? -1. This is not possible. Okay, 0 is equal to -1. This is not possible. So this system has a no solution. Okay, this is the Gaussian Jordan elimination. Okay, so now your today's assignment question is solve this linear equation with the help of Gaussian Jordan elimination. Okay, all students have to write in your handwriting and upload photos in or PDF in relevant application. Then I will put your attendance. Do not write only question, then I will put your absent. Okay, you have to solve this linear equation with the help of Gaussian Jordan elimination, and do not upload the same photo of your friend. Okay, now your today's lecture completed.